After you've made your scatter plot, we've talked about how to describe the scatter plot. So down there at the bottom, I'd like you to describe the scatter plot by those four things we talked about. The direction, was it positive or negative? The form, was it linear, quadratic, exponential? The strength, we said, is it weak, is it strong? And lastly, do you think there are any outliers in that data? So down at the bottom, see if you can describe the scatter plot. Again, whenever they ask you to make a description, you always want to include those four things. So what do you think for direction here? That's going to be form, and you're right. It's going to be linear. What about direction? Positive or negative? Positive, yeah. This one, as we go along, all of them are going up. So we do have a positive direction. Caleb is right. The form is linear. We can essentially make a line out of that data. What about strength? What do you think? Well, I thought you said something. What did you write down? Strong. Okay, I'd buy strong. Anybody say weak? You said weak. Okay. And maybe both of you could make a case for those two things. They're not overly spread out here, but they are not exactly in a line either, right? So I'd probably lean more towards strong, but you could, again, make a case for weak, possibly. Anything that looked like an outlier? If I drew a line here, does it look like anything completely out of place? No, I don't think that one's a little bit high, but it's not like it's totally out of the distance. If it were like down in here, that might be different, but probably don't really have any outliers. Well, as we were making those descriptions, which one was the hardest? Which one was the most difficult to decide? Probably the strength, right? This was probably the most difficult one to decide. So we need to have a way to be consistent because, again, we had a discrepancy between two people with strength. We need to have a way to be consistent to where, okay, this is the data, this is what I think the strength is, or this is what the strength is. And that's really what this next section talks about. Like it says down at the bottom in statistics, we often want to know how strong the relationship is between two variables. However, our eyes are not always very good judges of the strength. So we had to have a mathematical way of doing that. But what we're going to look at is what's referred to as the correlations between these variables. And that correlation is going to help us with the strength. So if you look at the back of that first page, we'll see how we can find the correlation between two variables. Well, first of all, when we talk about correlation is a lot of times referred to as the R value. So if they were asking for the R value, they're really asking about correlation. What correlation tells us? It actually tells us two things. Correlation is going to tell us the direction, which most of the time we can see from the graph anyway. Most of the time we can see if it's positive or negative. But it does tell me the direction. But more importantly, it's going to tell me the strength. One key part to this is correlation has to be a linear situation. I can't find the correlation unless it's linear. Now, I mentioned the other day, most of what we're going to do is going to be linear. So most of what we're going to do, we'll be able to find a correlation. All right, so how do we find it? Well, they gave you a table there, and within the table, it has our x values and our y values that you just plotted. And then it has these two columns here. One column says x minus x bar over the standard deviation. Well, what were they really finding when they do that? What do we call that? When we took x minus the x bar over standard deviation. Yeah, the z-score. So really what this column is asking you to do is find the z-score for the x values. So notice in this one, they told us that by filling in the parts, they're basically telling me that's the mean, and they're telling me this is the standard deviation. So if I want to find the z-score for the next one, now you don't have to write down every single part here. So you don't have to write down 20 minus 14 and a half and so on. You can type it to your calculator. But let's see what the z-score is. Now they went to 3 decimal places. I'm just going to go to 2. So if I take 20 minus 14 and a half, and get that answer, and I divide by 8.7, I get 0.63. If I do 0 minus 14 and a half, divided by 8.7, I get negative 1.67. All right, so why don't you go ahead and find the rest of those for the x's. Go ahead and find the rest of the z-scores for the x values. After you find all the x values, I gave you all the ones for the y values, so you can write those down. I know you know how to find the z-scores, so we use. I'll write in the z-scores that I got for the x's if you think I'm crazy. Tell me. I think I'm crazy for these lunges in June. All right, those are the ones I got. Maybe those seem way off.
I did 3 digits.
That's fine. Yeah, that's fine. So yours will actually be a little more accurate than mine. Okay, so for finding correlation, we just look at the x's, find the z-scores, and we look at the y values, find the z-scores. Now notice, you guys didn't have to do the y values, but it would have a different mean and different standard deviation. All right, the last column says the product. Well, product means we're going to multiply. So I'm going to take the z-score we got here times the z-score that I got here. And again, going to 2 decimal places should be enough. If you go to 3, that's even better. But let's see what our products would be for each one. Notice some of those will be positive. Some of them could be negative. Once you get your products, once you multiply all those, this one asks for the sum of those. So now we're going to add those up. Now don't forget they gave you this first one of 0.63, so make sure you include that when you start adding. But we're going to add up all those values now. All right, so we did the z-scores of x's, did the z-scores of y's, multiply those two things together, and now we've added up all those products. Here's the last step. The last step is we're going to take this total, and kind of like if you remember when we did standard deviation, We divided it by n minus 1. We're going to do that again. So n would be all the ordered pairs we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ordered pairs. So I'm going to divide by 10 minus 1, or in other words, I'm going to divide by 9. And that comes from 8 minus 1, 10 minus 1. So if I take 8.28 divided by 9, I get 0.9. This is our R value. Well, that's a lot of work. What's it telling us? Well, we said it should tell me two things. It should tell me the direction, and I can decide the direction just by the fact that this is positive. So if I get a positive R value, that means my graph should be positive. If I get a negative R value, that means my graph should be negative. Well, we already decided this was positive, so far so good. The second part is the strength. Well, 0.92, how does that tell me what the strength is? Well, if you look on your next page, I have a table there that's going to help us identify how we're going to label this strength. So notice they're a little more specific than what we've been doing so far. So far we just said, well, it looks weak, it looks strong. Well, now we're going to actually fit it into one of these 5 categories. So ours was 0.92. So if we look for 0.92 here, that's actually going to fit in this category here. So we would say that the correlation or the strength of this one is not just strong, but we'd actually go ahead and say this is an example of a very strong situation. So from here on out, when I ask you the question of strength, you're going to base your answer on the R value. And you're going to use this table in order to put it into a category. So that means this table needs to be someplace safe, someplace accessible in your notes. Because if you get an R value of 0.8, I would expect you to say, well, that's strong. If you got a R value of 0.15, well, I would expect you to say that's very weak. Not just weak, but very weak. Okay? So I'm going to base all my correlation descriptions off of this table here. So that's why you're going to have that table in. Yeah, good question. Does it change if it's negative? Well, the only thing that's going to change with the negative is the direction. So say I got a negative 0.8. Well, the negative just tells me it goes downward. 0.8 would still be in the strong category. Okay, that's a great question. All right, so let's see if we can answer some of these questions related to the R values or the correlation. Well, just below the table there, like it says, the sign of the R value will tell us the direction. The correlation is positive when the direction is positive. I'm not sure what happened on my coffee. But if the sign of the R value is negative, that tells me the direction is negative. So when we decided that 0.92 was our R value, that means the direction was positive, and we just said the strength was very strong. So how would I describe 0.75? Well, first of all, it's obviously positive. Where would it fit in our thing? In the strong category. Okay, so if I gave you an R value of 0.75, you'd say it's positive and strong. What about negative 0.15? Well, obviously negative. What's the strength? Very weak. Okay. So not too bad to use the table to make the decision. The number 3 is basically what Brittany was just asking. If I have a correlation value of negative 0.95 and another one of 0.95, well, really the only difference between those two things is the direction. One's positive, one's negative. As far as the strength, is one stronger than the other? Well, no, not in this case, because they would both be considered very strong. It would be like taking my picture that we just had. If I took these dots here and I just rotated them where they were going downward, well, the only thing that really changed was the direction they were going, not how close together they were. And we said the closer together they are, the stronger they're going to be. What do you think would be the absolute strongest R value that I could have? 1. Yeah. The closer I get to 1, if it were exactly 1, that means every single point would fall on that line. But the closer I get to 1 or -1, the stronger our situation is going to be. So here's what I want you to try. On the back, I have 4 graphs there. And there are 4 different R values listed. You have an R value of 0.1, R value of 0.8, -0.9, and positive 0.5. I want you to see which of those graphs do you think would correlate to or would match up with the positive 0.1. Which one would match up with the positive 0.8, and so on. So some things to think about. Direction is obviously a big one, but also the closer together those points are, the stronger the R value is, or the closer that R value is to either 1 or -1. So take a shot at it, and we'll see if we can figure out which one do you think matches those different R values.
That's what you do. That's right.
Okay.
Because we ran this.
Oh, okay.
That was no problem. Yeah. So you were doing that.
So of all those R values, only one of them was negative, the -0.9. So which graph should that go with? Yeah, the first one. So this is the only one that was negative. So R is equal to -0.9. That would be the good match there. Then you had some decisions to make. The next 3 were all positive. So let's think about what's the difference between 0.1, 0.8, and 0.5. Well, of those 3 things, which one would be spread out the most? 0.1, 0.8, or 0.5? Which one would be the weakest?
You said,
So 3 would look like it was spread out the most, you thought? Okay. Everybody agree, disagree? Okay, so if we're going with the most spread out, then that should be the 0.1, because 0.1 would be very weak, which means our points should be spread out. Well, how are we gonna make the distinguishing decision between 0.5 and 0.8? How can we distinguish between those two? Which one would be stronger? Which one would have the points closer together? Well, I mean, between 0.5 and 0.8, then we'll look at the graphs, but 0.8, okay? So you think 4 then was closer together, and it looks like they are. So if these points are closer together, then that's probably gonna be the 0.8 versus this is a little more spread out, but maybe not as much as what the other one was. As we said, 0.5. So just think about the idea, the closer we get to 1 or -1, the closer together the points should be. The weaker they are, the more spread out they are. Now, good news is our values, we're not gonna have to do them by hand very long. I'll show you how to do it on the calculator, okay? But just like standard deviation, I kind of wanted you to see where it came from first before we go to. So we'll keep working on that. Again, that's really part of your notes. So make that, or put that into your notes section. 2.2, remember we'll be due on Wednesday, so make sure you complete that. 2.1, if you haven't turned it in yet, please submit that.
Oh, yeah, we have to go through.
Yeah, you can turn it. If you have the paper copy, if you want to turn it in that way, that's fine. Or you can submit it anyway.
What? Yeah, me too. I always forget about it.